version 1.8 Ripley. I think that's the newest version. It'll let you know about updates. New version of PixInsight released 1.8.6. I haven't gotten it yet, so... Oh, maybe I have. I'm not sure what that meant. But usually it just gives you a little thing about updates, and then if you want them, you can check them and say, you know, update after I've finished working on this. Okay, let's go ahead and look at what we have. So in PixInsight, there's a really handy tool called Blink. It's under Processes, All Processes, and this is just in alphabetical order. And I'm going to choose Blink, and I'm going to open up my folder of lights and click and shift click to select them all. It's going to load all of those files up for me here in a list over here in the Blink window. All right, so here we go. All the files are loaded here in Blink, and what I can do now is I can just quickly step through them by hitting the down arrow or just clicking on one. And this is helpful for a few reasons. One, we can sort of evaluate the sky brightness as the night passes, because it applied an auto stretch to the first frame here. And then if we can see down here, we can see the sky got a lot darker. So when that happens, you might want to weight the files that have the darker sky higher than the files that have the brighter sky, and there's different ways we can do that, especially if we use the process called subframe selector. I'm probably not going to do that in this video just because it'll take too long to explain everything, but the main thing we want to do in Blink is just evaluate the frames for focus and for tracking issues, especially with a lightweight mount like I was using. There might be some tracking issues here. These all look pretty good. Sometimes it's hard to see exactly what's going on until you zoom in. Stars look pretty good there. And you can basically just quickly click through these and just take a look at the stars. Like in that one, they look a little bit more streaked than, and actually in those two right there. And let's say you wanted to then reject those frames. You can just say, let's move those selected files to a new location with this little button down here, and you could just make a new folder that's like rejected frames, something like that. I'm going to keep those in though. They didn't look too bad. Let me go all the way down here to the bottom and make sure my focus is still okay. Focus looks good here. Okay, but on this final one, I clearly see there's a problem. So see 8351 looks okay. But when I go down to 8352, there's this little artifact on all the stars. Zoom in even more so you can see what I'm talking about here. Come on. There we go. So you see how there's that little line coming out of all of the stars. That's usually an indication to me of probably I hit the mount somehow by stepping too hard near it, or actually manually running into it or something. And so I would not want to use this frame in my final stack because it might mess things up. So I would then just not use this final one when I'm stacking these. But most of the rest of these look pretty good, so I'm probably going to use all of these. But you really do want to blink through your frames, make sure that there's no big surprises. If in one you notice there was maybe like a satellite trail or a airplane trail, that probably would be fine, because through the stacking algorithm, it will automatically reject those pixels if it only shows up in 1 or 2 frames. So let's go ahead and close out a blink. Go up here to, over here on the left-hand side to Format Explorer. Go into DSLR Raw Format Explorer and click Edit Preferences. And what I like to do before I do any calibration is just set this to Pure Raw. So you just click on Pure Raw right down there. It turns off any image flipping. It doesn't try to debayer before calibration. It debayers after calibration. That's what this Create Raw Bayer CFA image means. And you go ahead and click OK to accept that. And now normally what I would do is I would go through the processes of subframe selector, image calibration, image registration, image integration, all these different processes separately to make my fully calibrated stacked image, because I like to sort of do it all manually to see what's going on as I go. But because this is a beginner video and I don't want to make it too long, I'm going to use a script. And a lot of times the scripts take a bunch of complicated processes in PixInsight and combine them together to make the whole thing easier. So I'm going to go to Script, Batch Processing, and choose Batch Pre-Processing. And this is very similar to like Deep Sky Stacker. You just load in your lights, your flats, your darks, your bias, and it basically takes care of the rest for you. But just like with Deep Sky Stacker, if you want to, you can go in here and go into more advanced topics. So I'm going to go ahead and add my lights here. Just select all of those except for the last one, because we didn't want that last one. 8352, click open. I'll select my flats. I'll select my darks. I'm just clicking these little add lights, add flats, add darks buttons at the bottom. And add my bias or offset. Okay, we have all of those loaded now. I'm not going to generate drizzle data, even though normally I might, because I don't want to get into that right now. Let's check our integration parameters here. So percentile clipping, that is not the one we want. Basically, it gives you an idea of the best rejection algorithm by just hovering over it right here. And there's different options based on the number of frames you've captured. And for over 25 frames or something like that, I think linear fit clipping is the best. So I'm going to choose that. You might want to change some of these parameters depending on what you see in the final stack, but a lot of times you don't know until you do it, so I just leave those on the default for now. Everything else here looks good. Over here, we want to tell it that these are CFA images. That means color filter array, such as a Bayer pattern, which is on all DSLRs. So I want that on. Bayer mosaic pattern, you can leave that on auto, but the most common one is RGGB. And VNG for the debayer method is fine. This probably doesn't matter if it's checked off or on, but we're not using FITS files, so I'm going to go ahead and uncheck that. Okay, and now we have to pick a reference image for our registration. And I remember the first one looked pretty good, so I'm going to choose lights and pick that first image. Basically, that's the one it's going to look to for registering all the other pictures against the star pattern. If we did subframe selector, we could mathematically know which was the best one in terms of focus, but since we didn't, I'm just going to use the first image I shot because that's right after I focused, meaning the stars should be in good focus there. And then I'm going to choose an output directory here. I'm just going to make a new directory called PixInsight process. Okay, this all looks good. I'm going to go ahead and click Run. It'll give me some warning about you know, you might want to integrate the lights yourself using image integration process. That's fine. We'll go ahead and click continue, and then just let it roll. And this takes a while. We're just going to let it do its thing and come back in a few minutes here. All right, once that's over, we can click exit there and say we want to exit that. Then you go to File, Open, go into this process folder, find master. If you want to look at any of these, if you notice any problems, you can, but the main one we're interested in here is the light master. So lightbinning1.xisf. I'm going to go ahead and click on open. Brings this up. This is in a linear state. So if I click on this little STF auto stretch button over here, we can sort of see what we have. And you'll notice the background here is very red. That's normal. That's the light pollution and basically just the channels being a little bit out of sync here. If we click on the actual screen transfer function process and we link the RGB channels, still red. Okay, never mind. Okay, but the next thing we want to do here is we want to go ahead and extract the background here. So we're going to go to Processed, Background Modelization, and usually I just start with the automatic and see how well a job that does. And so we're going to subtract the background and go ahead and just apply that. Okay, so here's what the background looks like. Basically pure red. And here is our image without that red background. Now it's a good starting point, but it did some strange things here. I think it overcorrected. The middle seems darker here, and then there's like a ring around that, which is a classic thing with automatic background extractor. So I'm going to go ahead and move that over to the side here and try my own hand at this, just using this as a reference so I don't accidentally put a point on any nebulosity, but I'm going to use dynamic background extraction. So I'm going to go to Process, Background Modelization, Dynamic Background Extraction. I'll go ahead and click on this to tell it that this is the active window here. Then I'll just go ahead and use these default parameters and see how it does. I'm going to go down to Sample Generation and click Generate. Okay, so with the default, it didn't place too many samples, and it placed one right in the nebula, so a little bit off there. So let's go ahead and play around with these model parameters a little bit. I'm going to increase the tolerance to 1. I'm going to increase the smoothing factor to 0.5. And down here under minimum sample weight, I'm going to decrease that to 0.5. And click Generate again. Okay, so that gave me a bunch more samples, but I'm still not having samples down here at the bottom. So I'm going to increase the tolerance just a little bit more, 1.3, let's say. And Generate again. Well, we still don't have any samples down there at the bottom, but that might be fine. We could just crop that bottom part away if it's too hard to model that part. The other thing I'm going to do here, though, is I'm going to look at where there is nebulosity here in my automatically subtracted one, and I'm going to get rid of any samples that are in that nebula part. So I'm going to move this one out of the way. one looks fine. This one is probably a little too close. I'm going to move that out of the way. This one is definitely in the dust there, so I'm going to move that over there. Okay, the other important part to do with dynamic background extraction is starting with this sample up here in the top left. I'm going to step through each sample looking at this screen right here on the dynamic background extraction panel and just make sure that I don't have anything like this where it's a big star is basically taking up the whole sample like that, because that will throw off the model. Then I might manually place a few samples down here in the lower part as well. Okay, and I'll go back up here to the top. Whoops, click on this one. Try to, there we go. Step through. There's another one that's on a big star, so I'm just going to move that a little bit over. You can see I'm doing this pretty quick, just looking for if any are hitting. Well, and this one, you know, has 2 stars right there in the field, so I might just move that off to the side a little bit. You basically just want these samples to be modeling the background and not stars or nebula features. Okay, looks good. I'm just going to put one down here in this corner. You can add as many manually as you want, but you don't have to add too many or it sort of throws off the model. Usually simpler is a little bit better. Okay, I'm going to go ahead and choose subtract here and apply. All right, if I look at the background, looks like that. If I look at this, you can see, let me just get rid of this, I'll minimize this. If I compare that to automatic, you can see the automatic sort of created this weird ring effect, while my dynamic background extraction looks a lot better in that regard. There's no ring effect. It looks pretty good. Out here towards the edges, there's still some artifacting and noise and things, but we can just go ahead and crop that away right now. Let me go ahead and get rid of this ABE. I'm going to go ahead and go up here to Process, Geometry, Dynamic Crop. Click on it, then reset it, and then just drag in from the sides here to get rid of all this sort of noise on the edges. And apply. And that's looking quite a bit better. The background is still a little bit blotchy, but this is super stretched. So most of that is just noise that we can, that's going to actually disappear once we do the real processing. Okay, next thing we can do here is I'm going to go ahead and save this. I'll just call it, put it in my process folder here, and I'll call it integration DBE crop. All right, now what I'm going to do is I'm going to extract a luminance, which you can click on this little button right up here that says extract CIEL asterisk component. But that basically means extract a luminance, and I'm going to open up screen transfer function and histogram transformation. I'm going to apply the screen transfer function, drag that down here by the little triangle, and apply it on the histogram. reset the screen transfer function, and now I have a stretched luminance right there. I'm going to reset my histogram transformation here and put this luminance in the view, and basically just continue to stretch that a little bit so that this histogram peak is right at about mid, like that. And this is basically just what we're going to use to put on as a mask when we apply some noise reduction. I like using a nice highly stretched mask like this to make sure that I'm not going to accidentally overly smooth any of these nebula features. This is actually maybe even not quite aggressive enough, so sometimes I'll also open up curves here and just open up a preview and just really try to make sure that all of the nebulosity part is going to be protected against this. That looks good. Okay, so I'm going to go ahead and apply this and invert it. Mask, invert mask. And now I have a nice mask that's protecting. The red is the part that protects, and letting in a little bit of noise reduction, which we're going to apply next, onto the sky. So I'm going to go to Process, Multiscale, Median Transform. I'm going to increase the number of layers to 6. Turn on noise reduction on all of them. And basically, with the smaller scale structures, we want to apply more noise reduction. So you increase the threshold. We'll do, I don't know, 10 or something like that on the first one. And you just sort of decrease it on each one. So I'm going to do 9, 7, 5, 3, 2, and 1, something like that, and just go ahead and apply that on this masked version here. This is my favorite noise reduction thing to do while the data is still in this linear format like this. And basically this is just like a blurring kind of noise reduction. It takes a very crunchy, noisy looking stuff and blurs the pixels together a little bit. I guess they call it smoothing, but it's basically blurring. And the multi-scale part is that it blurs on different scales, and you can set different amounts of blurring based on the scale of the structure. So what I'm doing here is the very small structures are getting more blurred together while the bigger structure is less blurred together. Okay, I'm going to go ahead and remove that mask, and you can see that it made the sky a little prettier, a little bit more smooth looking. And so the next thing we want to do is apply some color calibration to this. So I'm going to go to Process, Color Calibration, Photometric Color Calibration. We can search coordinates and just type in M42, search. It finds it, you say get, and it puts in the right ascension and declination for you. For focal length, it was 360, and pixel size, so 3.72. 360 focal length, knows the Orion deck, good, good, good. For white reference, I almost always use G2V star. And I'll go ahead and apply that. Basically what this does is it plate solves the image. It then pulls up catalog data and linear fits and changes the colors in RGB so that as many stars match the catalog data as possible in the field. And then it gives you a nice plot showing, you know, how many of your stars agree with the found stars. And so here it's telling me that it found 319 reference stars. Of those, 25 have problems, but that means it still has almost 300 stars to try to match the color against. And it's going to take all my colors and match those against those catalog stars. So very nice little color calibration tool built into PixInsight here. It's fairly new. I think like a year and a half to 2 years old maybe, and it works really well for me. Some people have had trouble with it, but I've always found it to work really well. Okay, so here's our white balance function plot. You can see for the most part the stars match up against this slope, and then there's a few outliers, but that's okay. Now it looks really weird right there, but that's because we just have to reset the auto stretch. So I just turn it off and turn it back on, and for the most part you're probably not going to see much difference there, but once we fully process it, it should really help with getting accurate color. All right, so we've done that. One more thing I like to do here on DSLR images like this is to neutralize the background, which the way we do that is we make a sample here of just the background with no stars in it, just through a preview. You just click on a little preview button and you drag out a preview. And then you go to color calibration, background neutralization. You set the reference image to your preview and you apply background neutralization. Again, doesn't seem to make much of a difference, but it helps later on. And then I can just kill that preview, reset my auto stretch. There we go. All right, next up, what I'm going to do is I'm going to apply one little thing more of noise reduction, which is SCNR green, because I see some green noise here in the image. I usually don't set this to the full amount. I do something like 60 or 70, and you just apply it and it takes out some of the green noise in the image. All right, now we can go ahead and apply stretching. We could try mass stretch, which is an easy way to do this. You basically just tell it what is the background and then it stretches it for you. But I'm going to do stretching by hand because I just like doing it by hand. So I'm going to open up histogram transformation here, reset it, open up this one, DBE, and then I'm just going to take this middle slider and move it over here until I can see the little histogram peak come up over a little bit, apply it, and you can see that applied an initial stretch. And I'm going to just do that again. And now I'm going to really back off and reset the black level here. And that might be good enough for now. I'd actually be interested to compare that to a mass stretch. Let's just see what the difference is here. So I'm going to undo what I just did. Let's go ahead and make a copy of this just by dragging it out by the little tab over here on the left-hand side. I'm going to rename this one Mass Stretch, and I'll rename this one HT for histogram transformation. Okay, and on this one, I'm going to do the same thing. I'm going to stretch it back out again. Okay, so that was my histogram stretched image. Like how it looks for the most part. And then here's my mass stretch. And so with mass stretch, you're just going to first define a preview of the background. I'm going to use this little area right here again. Then you can turn back off the auto stretch, go up to process, intensity transformations, mass stretch. For the background reference, choose that preview and then apply it. And it basically is doing the same kind of thing I was doing in histogram transformation, but instead of just applying those stretches to the same image, it first masks off the background, and so it's just stretching based on what is not background, and then it also does it in something like 100 iterations, while, yeah, it was set to 100 iterations, while you can see with histogram transformation, I did it in about 4 iterations. So sometimes it looks better, sometimes it gives the image a funky look, but while we're in this state of getting ready to stretch the image, let's just try both and see which looks better. Okay, it's done. I can go ahead and drop the preview here. And compare these two. Honestly, they're pretty similar. The mass stretch just brought up the background level a little bit beyond what is called for this image. But it maybe also retained the star color a little bit better. So if I can't decide between these two, I might just combine them with pixel math. So I can show that. I'll just do process, pixel math, and I'm going to do the expression editor here. Do 0.5 times HT plus 0.5 times mass stretch. All right, and I want to make a new image. So under destination, I'll say create new image. Oops, click the square to apply that. Okay, and then I get somewhere in between those two, which I actually think looks the best of those three. So, cool. I can save this off. Press Command S. I'll save this off as after stretch. And I think I want to try to remove some of that vertical noise banding I'm seeing. There's a script for that under Utilities, Canon Banding Reduction. There, that did it. So I applied it too aggressively the first time because I didn't know what I was doing, I guess, but with a less aggressive mode, it worked pretty well for removing that banding that I was seeing. What else is left to do? We could try making a range selection. So I'm going to do mask generation, range selection. Open up the preview here, increase the lower limit until it's basically just selecting the nebula and the stars. Make it a little bit fuzzier, a little bit smoother, something like that. And then it comes out like this. That's taking up too much sky, so I'm going to open up my histogram transformation and basically darken out the sky there. Okay, so I'll go ahead and apply this mask. And so now it's just selecting the nebula and the bright stars, and I'll go ahead and uncheck show mask so I can see what I'm doing. I'm going to open up a curves transformation and just apply a bit of saturation to all that. And so you can see, let me reset it. That's without. If I just sort of move up this saturation curve a little bit, it adds more saturation to the object. I'll go ahead and apply it. This is showing me if I now applied it again, but that looks like too much to me. So I'm going to tamp it down a little bit here. Apply it again. Cool, and then I'm going to go ahead and reverse the mask by clicking invert mask and move this saturation slider in the other direction to desaturate the sky just a tad. All right. And actually, let me open up that one more time. I'm also just going to bring the, reset this, go to RGBK mode, and I'm just going to bring the intensity of the sky down just a tad to the brightness of the sky, basically. Don't want to clip it to, really black like that. You want to leave in a little bit, but this is where it was. That's sort of a dull gray. I just like to make my sky a little bit darker than that, something like that. Messed it up. Try again. Grab it right about there and just bring it down just a tad. Okay. I basically like it like this. I'm just going to go ahead and save that off as after stretch and curves. But if you wanted to try to define the nebula features a little bit more, we could reverse that mask one more time. And we also would want to get rid of all the stars. Actually, let's just make a new mask. Get rid of this. Okay, so we could, instead of doing a mask that includes the stars like that, which we were using for saturating, we could go back to range selection, open it up again, and increase that smoothness slider until all the stars are out of it, and it's just got the nebula part here. Okay, and then I'll apply that just to show you which part of the image it's working on here, just there. And what we could do with this applied is go into intensity transformations, local histogram equalization. And what this does is it does a histogram feature, but just on the part we have masked, and it's sort of like a extra bit of contrast. It really sort of, it's similar to like the clarity slider in Photoshop. It just adds a bit of sharpness and contrast at a local level. And this kernel radius is saying which scale you're working on. So smaller scales, it's going to be a smaller kernel radius. Bigger scales, a bigger kernel radius. And then the contrast limit is what difference in contrast between 2 pixels do you want it to pick up on? So a contrast limit of 1 is not going to do much at all. 2 is going to be twice as aggressive. So 1.5 is usually where I start. And then the amount is how much of it you're applying. This is a good one to make a preview over the part of the image that you're working on, and then just bring up that preview in here. And so you can see by changing the kernel radius, it changes the fineness of the detail that it's working on. So for this image, I think something like 140 looks pretty good. I'm going to bring down the amount a little bit, 0.75. All right, go ahead and apply it. Okay, I'll close out of that, drop the preview, and I can just click undo and redo to see what it did. Helps if you're really far zoomed in here. Okay, so just look at this detail right here. If I redo, that's with the local histogram equalization. That's without it. So you can see how it just made the darker parts a little bit darker, which adds that local bit of contrast. There's another way to increase dark structures in your image, which is script over here, script, utilities, dark structure, enhance. So if you're interested in this, you can just try it out. It uses a masked approach. And sharpens with multi-scale transforms and things like that. And some pixel math expression, it looks like. See what it does here. Again, these scripts are often using processes in just creative ways. So you can pay attention to what they do here and try to recreate it yourself. Oh, whoops, you can't apply that to a masked image. Let me remove the mask. Try it again. Duh. The reason you can't apply that script to a masked image is because it uses masks, and so it gets confused if you try to apply it to an image that's already been masked, because it already creates the masks for you, is the idea. Okay, that's done. So I can hit undo, redo, and the main area where I see that did something is look right here under M43, before and after. So basically just figured out where those little dark nebula were and made them darker, which is nice. It adds a little bit of contrast to the image in a cool way. Okay, so I'm pretty happy with this. There's definitely a lot more I could do with it here in PixInsight, but I'm going to say that this is done. So I'm going to save it one more time, call it first try, PI, and then I'll also save it off as a PNG file. And it'll give me this warning about you're losing numerical accuracy by making it into an 8-bit file, but that's fine. Okay, all done with processing our M42 here in PixInsight. If you have any suggestions for future videos or other things you'd like to see, either with processing or acquisition or gear or anything, just let me know in the comments and I'll try to address those. Thanks so much for watching.